Binomial probability distribution. The binomial probability distribution is the probability distribution associated with a certain kind of experiment known as a binomial experiment. A binomial experiment is an experiment which satisfies four properties. The first property is that the experiment consists of a sequence of n identical trials. The second property is that there are two outcomes possible on each trial. We label one of the outcomes success and the other as failure. The third property is that the probability of success, which we write as P, does not change from trial to trial. Similarly, the probability of failure which is then going to be 1 minus P, does not change from trial to trial. The fourth property is that the trials are independent, which means that the outcome of one trial doesn't affect the outcome of another trial. So let's take a look at an example. Suppose our experiment is that we toss a coin 5 times. Now, tossing a coin 5 times is a sequence of n equals 5 identical trials, because every time we toss the coin, it's identical to the other times we toss the coin. Now, there are two possible outcomes on each trial, heads or tails. We label one as success, the other as failure. Here, we'll label heads as success and tail as failure. Now, the probability of success, which is going to be P equals 0.5, is going to be the same on every trial. The probability of failure, which is tails, is also going to be 0.5 on each trial. The trials are independent because no matter how many times we get heads or tails in a row, the probability of heads and tails is still going to be 0.5. So all four properties are satisfied, so this is considered to be a binomial experiment. Now, if an experiment is a binomial experiment, and then we define our random variable x as the number of successes in the n trials, then x has a binomial probability distribution. So in our example, if we define x as the number of heads in the 5 tosses, then since the experiment is a binomial experiment, x is going to have a binomial probability distribution. Now, the reason it's useful to know that our random variable x has a binomial probability distribution is because we know the probability function for a binomial distribution, so we can use the binomial probability function to compute probabilities for the random variable. Now, the binomial probability function is given by the formula f of x equals n choose x, p to the power x times 1 minus p to the power n minus x, where nx is the formula for combination, which is n factorial over x factorial n minus x factorial. Now let's look at an example. Suppose that we have a binomial experiment with n equals 2. So there are 2 trials, and the probability of success is 0.4. Suppose we want to calculate the probability of having one success. So this would be f of 1, which would equal to 2 choose 1, since n is equal to 2 and x is equal to 1, times 0.4 to the power 1 times 1 minus 0.4 to the power 2 minus 1. So n choose 1 is going to be equal to 2 factorial over 1 factorial times 2 minus 1 factorial times 0.4 times 0.6 to the power 1. So 2 factorial over 1 factorial times 2 minus 1 factorial is going to be 1 times 0.4 times 0.6 is going to be equal to 2 times 0.24, which is going to be equal to 0.48. So the probability of having one success in this experiment is 0.48. Now let's calculate the probability of having at least one success. Well, that means we're looking at the probability of having one success or 2 successes. Since there are only 2 trials, the maximum number of successes is going to be 2. Well, this is going to be equal to the probability of 1 success plus the probability of 2 successes. Now, we've already calculated the probability of 1 success. We know it's 0.48. So let's quickly calculate the probability of having 2 successes. So it's going to be 2 choose 2 times 0.4 to the power 2 times 1 minus 0.4 to the power 2 minus 2. So this is going to be 2 factorial over 2 factorial, 2 minus 2 factorial. 0.4 squared is going to be 0.16 times 0.6 to the power 0. So 2 factorial is 2 times 1 over 2 times 1 times 0 factorial times 0.16 times 0.6 to the power 0 is simply going to be 1. Now 0 factorial is equal to 1. That's just the rule. So the first part here is going to be 1 times 0.16 times 1, which is going to be equal to 0.16. So this is going to be equal to 0.48 plus 0.16, which is going to be equal to 0.64. Now, the expected value and variance for a random variable with a binomial distribution are given by the formulas n times p and n times p times 1 minus p. So in our example, n was equal to 2 and p was equal to 0.4. So the expected value is 2 times 0.4, which is equal to 0.8. The variance, for example, would be equal to n, which is 2, times p, which is 0.4, times 1 minus p, which is 0.6. So it's 2 times 0.4 times 0.6. So 0.4 times 0.6 is 0.24. So it's 2 times 0.24, which is equal to 0.48. And if we want to find a standard deviation, we simply just take the square root of 0.48.